Hi, this is Isha. You're watching a video with justtutors.com. In today's video, we'll be learning about coordinate geometry. In this lesson, we'll learn about the distance formula in coordinate geometry. Let's start a lesson with some warm-up questions. You can pause the video here to try these questions. So now let's discuss the answers. Here we need to write coordinates for any 2 points for each one of these. So here you can check the answers that if you're working on the x-axis, you must put a point for the y as 0 because we are not moving anywhere on the y-axis, so it needs to be a 0 for the y. For the next one, which is on the x-axis, if you're writing the points, you must have a 0 on the x because we are not moving anywhere on the x-axis, so it needs to be a 0 there. In quadrant 2, you need to have x coordinates, the point on the x-axis as negative number and the points on the y-axis as the positive numbers. In quadrant 4, you need to have x in positive and y in negative. So I'm sure if you were careful enough, all your answers must be correct. Now let's see how to complete these given blanks. The distance of a point from the y-axis, it's called x-coordinate or abscissa. For the second one, the distance of a point from x-axis, it is called y-coordinate or ordinate. If your answers are correct, it's really wonderful. Let's learn more about coordinate geometry. Let's start to work with the distance formula. Here we learn how to find the distance between 2 points on a Cartesian plane. Let's look at the 2 points P and Q, where P is given as x1, y1, Q is x2, y2, where x1, y1, x2, y2 are the points on the x-axis and the y-axis respectively. Let's learn how to find the distance between P and Q, where distance can be denoted as a small d. As you can see here, d. Now, as we can see that it is forming a right-angled triangle, so we can apply the Pythagoras theorem in order to calculate the hypotenuse, which is the d. The value of base here, it is x2 minus x1, and the value of perpendicular, here we have y2 minus y1. Keeping them in the Pythagoras theorem, the equation, this is what we have as the distance formula, that is d equals y2 minus y1 within brackets squared plus x2 minus x1 within brackets squared, and adding them together and taking the square root of it gives us the hypotenuse or the distance between the two. Let's see example with this to make it more clear. We need to find the distance between the pair of points given to us in the question. What we need to do here is, we need to mark what is the value of x1, what is the value of y1, what is the value of x2, and what is the value of y2 we have. Then, using the distance formula that we have just learned, keeping all the given values in it, we calculate our answer. You can pause the video here, try this question and match your answer with the solved example. Similarly, in the second one, we'll do the same way. However, we'll be a little careful with the negative signs that we have in our question. Now let's move ahead to see what are the applications of distance formula. Do the points given to us P, Q and R form a triangle? Here the triangle, it is not given to us. This is just in order to check our answer, we have drawn this. So in the solution, we see that first we need to find the difference between the points PQ, QR and RP so that they form a closed shape. We find the value of each. PQ comes out to be square root of 50, QR is square root of 52 and PR is square root of 2. Observing these answers, we see that we can write it as pq squared plus pr squared equals qr squared. That is our Pythagoras theorem if we observe it. So what we see here is that it is not just a triangle, but it is a right angled triangle. And also we need to know that the sum of the squares of two sides is equal to the square of the third side here. This is what we have as the statement for the Pythagoras theorem, and this is true over here. So it is a right angled triangle. Now let's see the next example. If the point x and y is equidistant, that is at the equal distance from the given 2 points, we need to find the relation between x and y. Again, what we'll do, we'll assume that x and y is denoted by a point P. We suppose that this is point A and this is point B. We find the value of AP and BP and then square the answer in order to make our equations more simple. And then because it's written that they are equidistant, we equate them. We equate the value of AP squared equals BP squared. We keep them in equation, we solve them. You can pause the video here to see how we need to work with it. You can try yourself and then match your answer. And at the end, we see that the relation between the two is that x minus y equals 3. With this, we have some practice questions for you. You can again pause the video and now try all these questions. And when you're done with the questions, make sure that you check your answers with the answer slide provided at the end. Thank you for watching this video. For more, please visit justtutors.com.